Welcome to part 2 of the Polynomials review and preview. We're going to jump right in. In this one, we're going to finish up looking at tiles and looking at add and subtract briefly, which should be reviewed from grade 9, and I'll refresh you of a couple details. So let's jump right in. And we are jumping back to the workbook. We are on page 267, which is where we left off yesterday in our lesson. And we're going to quickly talk about algebra tiles. So in your workbook, we have a legend here refreshing us of algebra tiles. There's 3 things we're going to deal with. Constants, which are referred to as 1. So if I had plus 5 as a constant, I'd have 5 of these little guys. X's, my skinny rectangle, that's how many X pieces I have. And X squareds are the big square. And I'm going to talk about these more later. The key that your workbook uses, the shaded ones represent positive, the unshaded represent negatives. That's just a key. That could easily flip the other way. You could see something online that says the opposite. You could get a quiz, exam, whatever, worksheet. They all say a different key. This is the one your workbook uses. And I'm going to show you in a sec, right? Physical tiles that I would have in the classroom, those are different colors too. And X is just, a variable. These could represent A's and A squareds or B's and B squareds. It's just a letter. So the first thing we're going to do, and this is really all I'm going to ask you to do with tiles for now, is to identify what we're dealing with. So the first one, you have a big square, and I know big squares were X squareds. But then because it's not shaded in, I know it's negative, so negative X squared. And then I have 2 of those rectangles. They're shaded in, so it's positive, and I know those represent X's. So 2 X's, and because they're positive, I'll add them. Plus 2X. And then a positive 1, the little 1 kicking around. And I can represent that polynomial, negative X squared plus 2X plus 1, could be represented by those tiles. Okay, the next question. I look at that, I see 2 big X squareds. So I'll start with that, 2X squared. And then something convenient that I notice is I have a negative X and a positive X. And this is something we dealt with a lot last year. It's something we're going to continue to look at, is if I have plus or minus the same thing, I don't really have anything, right? If I gave you $50 and then took away $50, you're still at 0. If I handed you an apple and then took away an apple, you don't have any apples. So if I have a positive X and a negative X, I circle my draw and arrow away, those disappear. Okay, that's called a 0 pair, and it's a concept we looked at last year. And you can just cross them off. So again, I have a 0 pair of a 1 minus 1. I gave you $1, took away $1, you don't have anything. And another one. So those I consider gone. So I don't have any X's in this polynomial. I only have a negative 1. The way I would specify a negative is by subtracting. So really, when I simplify this thing, when I take away or combine the unnecessary pieces, that's all I have, 2X squared minus 1. Okay. With tiles, last year we can add, subtract, multiply, divide. We can do all sorts of things with tiles. This year, I'm really going to only ask you to look at tiles for multiplying and then dividing, or a new concept which is called factoring that we're going to look at later in this unit. So the add, subtract, I'm not going to worry about as much. The big thing is, can I recognize what polynomial these tiles represent? Okay, with that, I'm going to go to this. So you don't have this in your workbook. If you wanted to, you could jot it down on some blank paper. It's not a lot. It's just a little page where I want to talk about these tiles and offer just a little bit more detail, a little bit of clarification. So these are also called area tiles because they represent an area. They have a length and width. And they have a very specific length and width that I want to talk about. And this is going to be important as we move later in the unit. So a 1 tile is called a 1 tile because it has an area of 1. Now we could label that. The length is 1. The width is 1. The area, if I calculated the area of a rectangle, it's base times height, or length times width. This dimension, 1, times this dimension of 1, area equals 1. Okay. The next one, if I move to the X tile, it's called an X tile, but you wonder, why is it called the X tile? Well, the length And something I want you to notice, and something I'll show you, I'm going to pull up some physical tiles. Okay, here are my tiles that we'd have in the classroom, different colors, but same idea. This is the ones tile that we just talked about. And what I want you to notice is it perfectly lines up with the side of an X tile. So if this X tile had a dimension of 1, the top and bottom of an X tile would be the same dimension. So I go back to my sheet and I fill that in. I know that dimension. Okay? So the length is 1. The width, I'm not sure. But here's where we use our detective skills, we use our logical skills, and we say, well, if the area of an 1 tile was 1, the area of an X tile is probably X. So you ask, well, what would the width have to be to get an area of X? And I remember, okay, well, it was length times width. So 1 times something equals X. The only thing that fills in that equation is X. The dimensions of an X tile are 1 by X. Great. And now let's move on to the X squared tile. And maybe I'm thinking it has an area of X squared because I have a lot of logic and I kind of see the pattern. It's called an X squared tile because, well, it has an area of X squared. Well, let's talk about it and let's look at those tiles again. Here's the X squared tile. I know it's a square, so I know whatever this dimension is, the other dimension has to be the same thing. And just like I did before, if I take the tile, I already know this has a dimension of X. And they are designed to line up perfectly. Dimension of X. And I could check with physical tiles if I wanted. Dimension of X. Okay, so those dimensions are important, knowing what I would refer to. X by X, X by 1, and 1 by 1. That's going to be really important later in the unit. This is an X by X square. Dimension of X, dimension of X. Okay. All right, well, that's the tiles. Okay, you'll have some homework questions about them, but ultimately the reason we introduce them now is so that we can use them later on in the unit. All right, now back to your workbook. So this would just be on the next page. So I think we're on 267. This is at the top of 268. It says use algebra tiles to determine the result of this addition. I'm going to cross that off, okay? Or I guess I shouldn't cross off all of it. We're not going to use algebra tiles, okay? I'm not going to ask you to do algebra tiles to add and subtract. We're going to bring them back later. What I need to remember, okay, when I am adding polynomials, first thing, an equal sign down all of this. Every new statement is an equal statement. So this is equivalent or equal to whatever I'm going to write here, okay? 2x squared plus 1 plus x squared minus 2x minus 3. With anything in polynomials, I always look for information out front. So the first bracket, there's no information out front of it. I'm not multiplying it by anything. I'm not subtracting. I'm not doing anything. So these terms remain the exact same. You had a 2x squared and you had a plus 1. Okay. The next bracket or the next polynomial has a plus sign out front, meaning I am bringing in, I am adding all of these quantities. I'm not multiplying by anything, I'm adding them. So I'm adding x squared. And then I am adding negative 2x. If you are adding a negative, this goes back to integers, this goes back to 7th grade. Adding a negative, an easier way to say that is just subtraction. Okay? And then again, I'm adding the negative 3. So what you remember from grade 9 is probably, well, hey, if I have an addition, the x squared, the minus 2x, it all stays the same. The brackets didn't do anything there. The brackets weren't important. My line is all of the same terms with all of the same signs. Now we do what's called gathering like terms. Okay, so I'll have a new equal sign. And I'm going to gather the terms that are the same. So what I see is I have x's, I have x squareds, and I have constant. I'll start by putting all the x squareds together, and maybe I identify them with a little underline. I say, hey, you have 2x squared, and you have x squared, and those are like terms. Those are things that are the same. Those are those big square tiles. And then I have minus 2x. That would be an x term. Those are those skinny rectangles, but I don't have any other x terms. And then I have plus 1 and minus 3. Those are constants. Those are the one tiles. And I gather them together. 2x squared plus x squared. Those have the highest degree, so I write them first. Notice the sign comes with it. Then the x term, minus 2x. That was the only x term. There's nothing to gather. And then my constants, plus 1, minus 3. So I have my x squared terms together. I have my x terms, which there's only one of, and I have my constants. And now we do what's called combining the like terms. So the things that I just grouped together, the things I put together for convenience, I can actually blend them. You have 2x squared and you have 1x squared. We don't write the coefficient of 1 because mathematicians are lazy, but we know that it's a 1 there. 2x squared plus 1x squared is 3x squared. I had 2 apples, and then I got another apple. Altogether, I have 3 apples, or in this case, 3x squareds. Minus 2x, there's no other 2x, or there's no other x term, so I can't combine it with anything. And then plus 1 minus 3. So I had $1, up $1, positive $1, subtract 3. I was $2 in debt, so subtract 2. Positive 1, subtract 3 is negative 2. That's why it's subtract 2. And there's my answer. You're probably really familiar with addition from grade 9. If that's something that we're not super confident in, I'm going to post separate videos, or maybe just one video, about adding and subtracting polynomials. Okay, and I'm just going to find them on YouTube. I'm not making those videos. Those are videos you can go to if you need to review, because this is a grade 9 skill that we need to be confident in, and maybe just an extra refresher video would be useful. Okay, let's move on to subtraction. Okay, it says subtracting a polynomial is equivalent to adding the inverse polynomial. What that statement means is maybe a more common phrase, add the opposite. Okay, which is what we're going to do, and I'll probably show it in a different way, but it's adding the opposite. And again, we're probably familiar with this from grade 9. So I'm not going to use algebra tiles, nor would I ask you to. What I look at in this subtraction, I'm going to write an equal sign. There is nothing in front of the first polynomial, negative x squared plus 3x minus 2. There's nothing out front, so everything stays the same. Negative x squared plus 3x minus 2. In the second polynomial, you have a subtraction out front. And what that means is all 3 of these pieces, all 3 of these terms need to be subtracted, and this is where add the opposite comes in. Okay? Another way I like to think about it, and a way that I'll visualize it, is that I distribute the negative. All 3 terms in this polynomial need to be subtracted. So minus 2x squared, okay, the 2x squared gets subtracted, minus negative x, minus negative x. Subtracting a negative is just adding a positive. That's that add the opposite idea. So the positive 2x squared becomes a negative 2x squared. The negative x becomes a positive x. I'm adding the opposite. I'm subtracting as I go. And minus negative 1, I'll subtract the negative, that'd be plus 1. So I did the same step I did above, but I just had different information in front of that polynomial. Now, just like before, gather your like terms and simplify. Okay, I've got a minus x squared and a minus 2x squared that I'll bring together. I've got a plus 3x and a plus x, so I actually have 2x terms this time that I can bring together. And I have my constants, minus 2 plus 1. So I'll bring those together. Negative x squared minus 2x squared, the sign comes with it. Now your x's, plus 3x plus x. And now your constants, it was a negative 2, so subtract 2, plus 1. I have my x squareds, that's one type of term. X's, that's a different type of term. And constants, that's a different type of term. Alrighty. Negative x squared minus 2x squared. You lost one of something, you lost 2 more. Altogether, you lost 3 of those x squareds. Plus 3x plus x. I have 3 of something, I get 1 more. I have 4 x's. And the constants, you lost $2, negative 2, but then you gained 1 back. So I would only be at negative 1. And there's your subtraction. So again, I'll post a separate video about adding and subtracting polynomials where if you want a little bit extra, go watch those videos. Okay? But other than that, I am going to move on. And I think we really only have a couple examples left before some more work time for today. So addition and subtraction of polynomial expressions. Let's just talk about like terms for a sec. Okay. Like terms are terms with the same variable raised to the same exponent. So not only do I need to have the same variable, the exponent piece needs to be the same as well. So like 3a, 7a, a. Those are all like terms because it's just an a. 2x cubed, 1/5 x cubed, and negative 4x cubed. Those are all like terms. They all have the x cubed. Unlike terms are when I have either different variables or different exponents. As soon as one of the pieces is different, they are not like terms. So x cubed compared to x squared compared to an x. Yeah, they're the same variable, but their exponents are different, so they are not like terms. I cannot combine them. And the other example, an x term and a y term, yeah, those are different. Those are unlike terms. Okay? And what it says is like terms can be added or subtracted to produce a single term. Absolutely. Absolutely. So that's what we're going to do in this example. Okay, simplify the following polynomials by collecting like terms. 3a minus 4b plus c plus 3b minus 5c minus 3a. So an addition problem. I start by removing the brackets. The first polynomial, there's no information up front. I'm not multiplying it by anything. It's just that polynomial, so it all stays the same. The next one is addition. I'm adding 3b. I'm adding negative 5c. I'm adding negative 3a. Addition, the sign stays the same. Adding a negative, that's just like subtract. Adding a positive, it's just like add. The signs stay the same. Now I gather my like terms. And in this example, I have a's, I have b's, and I have c's. Okay, well, put the a's together because I'll go alphabetical because why not? You have 3a and minus 3a. Now my b's, minus 4b plus 3b. And then my c's, plus c minus 5c. So I gathered my like terms. The a's all combine, the b's all combine, the c's all combine. Well, this one's interesting, and I'll talk about it. 3a minus 3a. Huh. You had 3 of something, you lost 3 of something. I guess you don't really have that thing then. I gave you $3 and then took away $3. You don't have anything left. So I could say 0a, because that's how many I have. I'll come back to that later. Move on to the b's. Minus 4b plus 3b. That'd be minus 1b. You lost 4 of something, but then you gained 3 of them back, so now you've only lost 1. And finally, my c's. You have 1c, and then you lose 5. Negative 4c. That technically has all the pieces, but it's not the best way to write it. I would never write 0a. I just wouldn't write anything. Okay, so I'm not going to include that piece. Negative 1b, or subtract 1b, I don't bother writing the coefficient of 1 because I know it's a coefficient of 1 if it's not written. So it would, instead of negative 1b, it would just be negative b, and my minus 4c stays the same. So just a slightly easier way to write the same thing. Okay, b is written vertically. It's stacked on top. Maybe it goes us back to elementary school when you'd stack numbers on top of each other to do addition, subtraction, multiplication, division. But we're not going to do that. If I see a question like that, maybe I could look at it that way. For me, I find it easier to look horizontally. I have my 2 polynomials, and I am subtracting them, and I'd proceed like normal. The first polynomial has nothing out front. There's no addition, subtraction sign out front. It's just the polynomial. All the pieces stay the same. The next one, you are subtracting that polynomial, which means I'm subtracting all 3 terms. I need to distribute that negative. I need to say that it's a subtract 2x squared. A subtract negative 3x would be a plus 3x. And a subtract negative 1 would be a plus 1. I need to distribute that negative. That's huge. And now it's just like any other question. Gather your like terms. 4x squared minus 2x squared. I put my x squareds together. Now my x's, which are different, negative 9x plus 3x. And finally, I finish with my constants, which are the other type of piece, which is a plus 6 and a plus 1. And I've gone through and I've collected all of the different pieces. 4x squared minus 2x squared, you're left with 2x squareds. Minus 9x plus 3x. Negative 9 plus 3 is negative 6. So minus 6x. And your constant, plus 6 plus 1 is plus 7. There you go. So a little bit more addition and subtraction for you. And we are on our way. All right. Question here, number 9. It says simplify. Well, what simplify means is what we've been doing. Gather your like terms, put them together, and write your final answer in the proper order, which if we gather our terms together in the right order, we'll be fine. So for the first one, I start by collecting the x squareds. Those are the biggest degree, negative 2x squared minus 6x squared. Then I go to the x's. I've got a positive 4x. It doesn't have the plus out front, but it's not a negative, so I know it has to be positive. And a minus x on the end. And the only thing you have left is your constants, plus 3 plus 5. Okay, and now I gather them. Okay, I put them together. Minus 2x squared minus 6x squared. You lost 2 of something, you lost 6 more. Altogether, you lost 8x squared. Plus 4x minus an x. I'd be at positive 3x's. And your constant, plus 3 plus 5 plus 8. There you go. Which is what we've been doing. Sometimes I won't give you an add subtract. Sometimes I'll just give you a simplify. Okay, the next one. A squared b minus ab squared plus 4a cubed b minus 7ab squared plus 5a squared b. This is a tricky one. Okay, this one's a little bit weird, but ultimately I can figure it out. If I'm going to combine like terms, the first thing I'm going to do is identify my like terms. And I'll figure out the degree later because this one's maybe a bit more complicated. I'll start at the very front. A squared b. What I am looking for is another term where it has an a squared and a b. So the next one is a b squared. Similar but not the same. I need the a to be squared and the b to not be. Plus 4a cubed b. No, that's different. It needs to be an a squared, not an a cubed. Minus 7ab squared. No, I need the a squared. Plus 5a squared b. Hey, that one is the same. So I'll put those together. A squared b plus 5a squared b. Those were grouped together. Next, I'll just go left to right. Minus ab squared plus 4a cubed b. No, that's not the same. It has an a cubed and it can't. Minus 7ab squared, that is the same. Those are the same type of terms. So minus ab squared because it was a minus and minus 7ab squared because it was a minus above. That's that type of term. And then the only piece I have left is my only term. So I actually don't have anything to gather with it. It just comes down all on its own. And it'll continue to my final answer. A squared b plus 5a squared b minus ab squared minus 7ab squared plus 4a cubed b. I have my terms. They are all copied down, but now they're in a more convenient order for me to say you have 1a squared b plus 5a squared b's. That means you have 6 of those a squared b's. Minus an ab squared minus 7ab squared. I lost 1 of something. I lost 7 more. Altogether, I lost 8 of that thing. And finally, the plus 4a cubed b. Nothing to combine, nothing to get bigger. The last thing I have to do in a question like this that I haven't taken care of yet is put it in the proper order, okay, which would be based on degree. So the first term, 6a squared b, has a degree of 3. Exponent of 2 and an exponent of 1 makes it a degree of 3. The next term also has a degree of 3. Exponent 1, exponent 2 makes it a degree of 3. And the last one, exponent 3, exponent 1, has a degree of 4. So written in the proper order, the last term actually has to go first. And then since these ones have the same degree, you can put them in whatever order you want, as long as the 4a cubed b is written first. So I'll leave them in the order they were just in, but moving the 4a cubed b to the front. And now I satisfy descending order of degree, and I'm good to go. Okay, so multiple variables might be a little new from grade 9. They need the same variables and the same exponents on them in order to actually combine, in order to be the same terms. They need to be the exact same piece. Okay, let's move on. I think we're moving on to the last question here, and then I'll give you some homework time. Nope, I was wrong. And that is the last question. So I'm going to set you up on your homework and let you get going on there. Page 269, which is what you started yesterday. 1 to 5 and 7. This part right here was yesterday's homework. So only the new stuff, 10, 13, 14, and 17 to 20. That's what you do for homework today. Again, the key is at the end of that page, the last assignment. You can see if you're getting the questions right. Anything you're struggling with, anything you have a question, click on the Google form for today and send me that question, and I'll make a video response. And I will also post an additional video explaining addition and subtraction of polynomials if you want to go to that for a little bit of extra help. Other than that, have a great day, and I'll see you guys tomorrow.